All right, so we're still working on frequency distribution tables. Let's imagine for a moment that we're going to build one of these. We've got a bunch of our raw scores. All our data is in a big disorganized pile. And so we know that the first thing we're going to do is build a column for our raw score categories, build a column for our frequency values, and then we're going to look into that data to find our highest value score and plug it into the top. So let's say we go through our data and we find the highest value score, and we're going to say it's 77 points on whatever it is we were measuring. So we know we plug in a 77 there, and then we're going to list every possible score going down to the lowest score in the set. And let's say the lowest score in the set was a score of, let's say it's all the way down at 12. If the highest score is 77 and the lowest score is 12, we would need to make a table that has a spot for 77, 76, 75, 74, 73, 72, 71, 70, 69, 68, all the way down to 12. That would take 66. If you just subtract it, you're going to think 65. But it takes 66 rows of data. Remember, we're basically doing descriptive statistics here, and we said part of the goal is to summarize and organize our data. A table that's 66 rows long, that's too much. I mean, you would have to have it like a fold out in a textbook or in a journal or something. It's too much. It's not summarized enough. No one wants a table with 66 rows to plow through. It's just simply unwieldy. So when we have a set of data that's going to result in a really long table like that, what we're going to do is instead build a grouped frequency distribution table. So in a grouped frequency distribution table, what we're going to do is establish class intervals. A class interval is a grouping or a packaging of raw scores. It's not a raw score, it's a little mini set of raw scores. It's a bundle of raw scores that all come together. So if you look in your textbooks, find table 2.2. If your book is formatted like a regular book, it's on page 41. If you're looking at digital and change your font size, it could be any table, or I'm sorry, any page. But the table number is table 2.2, right around page 41. And what we see there is an example of, at the bottom there, table 2.2, an example of a grouped frequency distribution table. We're going to get into analyzing that table in more detail in just a moment. But notice that down the left-hand column, the X column for that, you don't see individual scores, you see little sets of scores. So for example, on the very top it says scores of 90 through 94. That's a class interval. That's a grouping or a packaging of raw scores together. So instead of listing every possible score, we're going to list these class intervals, these little groupings of scores, just like you see in that example. So in order to build these, the same rules apply as for a frequency distribution table, in that you need at least a column for your X values, you need at least a column for your frequency values, you start at the highest values and you go to the lowest values. Those rules all basically remain in place. But we're going to add 4 more, they're called rules, I just said rules, they're kind of guidelines, some of them are a little smushy, but 4 rules for building these tables. So the first thing is that our finished grouped frequency distribution table should have approximately 10 class intervals. In other words, we talked about initially, I can't remember what numbers I made up now, but 60 some odd rows in the table. What we're saying is we're going to condense that down until there's about 10 rows, 10 packages of scores, 10 bundles of scores, about 10. It sometimes will work out exactly to 10, but often it will not. So what we really say is anything between 8 and 12 is good to go. So 10 is sort of right in the middle of that, but a minimum of 8, a maximum of 12. So let's look at that table, 2.2, and go down how many class intervals does it have. 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 class intervals. The top one, 90 to 94. The bottom one, 50 to 54. So it meets that rule. It is in the correct zone. It's about 10, 8 to 12. So it's been condensed the correct amount. If it started with 60, I'm going to say 67 rows, and you condensed it down to 3, well, you've compacted it too much. If you condense it down to 50, you haven't condensed it enough. So we're kind of looking for that golden zone, that just right zone of how much to compact it. And we want to compact it till there's about 10 rows, 10 class intervals in it. We want the class interval to be a relatively simple number. In other words, how many scores are we bundling together? This is what's called the width of the interval. So when someone says how wide is the class interval, what they're really saying is how many scores are in that package. So again, let's look at table 2.2 for our example. That very top one, 90 to 94. How many scores are in that? Well, again, you can't just subtract it. If you subtract it, you're going to say 4, but you're going to be wrong. So just use the good old count on your fingers method. 90, 91, 92, 93, 94. So the width of that class interval is 5 points wide. It has 5 scores in it. It could have 2 scores in it. However many scores it has, that should be a relatively simple number. What I often say is imagine a number that first, second graders count by easily. 2, 5, 10, 20. What we don't want are little bundles of numbers that are 7 points wide. Nobody counts by 7s. We don't want things that are 4 points wide. Nobody counts by 4s. I mean, we can, we're adults, we know how to count, but it's not a cultural convention we use. So when we say we use bundle together a simple number of scores together, a width of 2 scores, like we see here in the book, a width of 5 scores, a width of 10 scores, a relatively simple number to count by. Of course, we want every interval to have the same width. So again, if we look at table 2.2, that top interval is 5 points wide from 90 to 94. The second interval down, 85 to 89, 85, 86, 87, 88, 89, that's also 5 points wide. Third one down, 80 to 84, 80, 81, 82, 83, 84, 5 points wide. Every one of those class intervals in our textbook example is 5 points wide. So we don't want one that's 2 points wide and one that's 5 points wide and the next one is 2 points wide and the next one is 10 points wide. Whatever the width is, they all should have the same width. Again, consistency is what we're looking for here. And this last one for a lot of students is kind of the weirdest one to see. The bottom score of your interval. So if we look at our example we're looking at here, table 2.2, and go all the way to the lowest score in that table, go down to the bottommost interval and look at the lowest score on it, it's a 50. What this is that it says that that number, that 50, needs to be a multiple of the width. In other words, it needs to be evenly divisible by the width. Well, the width is 5 points, the score is 50. Is 50 evenly divisible by 5? Yes, it is. So it meets that requirement. What that really does for us is it tells us that we want to set up the table. For example, that bottom interval, as it is, says 50 to 54. That's good because the bottom score in that interval is evenly divisible by our width, which is 5. What we don't want to do, instead, we could have built the table to say that the bottom interval is 51 to 55. We don't want that option because now the bottom score is no longer a multiple of the width. 51 is not evenly divisible by 5. So in addition to the regular frequency distribution table rules, we have these extra things to deal with. Now, I will expect you for points to build for me a frequency distribution table. Regular old table with columns for proportion and percent. You should be able to do that, no problem. What I will not ask you to do for points is to build one of these grouped frequency distribution tables. Not because I don't think you're capable of it, but because they take a long time. There's some trial and error. Well, how many points wide do I need to make it to get to around 10 class intervals to make it 10 rows wide? Oh, should I use a 5? Should I use a 2? Should I use... So that it's time consuming. So what you will do for points instead is I will absolutely show you a completed frequency distribution table and ask you what's wrong with it. I'll put mistakes in it and ask you to find them. So what you really need to do for grouped tables is know these rules in action. When you're looking at a table, be able to say, oh, they screwed that up because they didn't do this part right. So you should be able to evaluate the group tables. You should be able to build a basic one, but I'm only ever going to ask you to evaluate the grouped ones. So there we are. We will continue working with this in the next video clip.